Welcome to the Explainer. Every single second you're online, you're using something you probably never even think about, an IP address. It's kind of the hidden engine of the internet, and today we're going to break down how it all works using one really simple idea, a digital post office.
I mean, really think about it for a second. You type a website into your browser, hit enter, and boom, a page from a server maybe halfway across the world just appears on your screen. How does that little packet of data navigate the entire internet to find your specific device among billions of others? Well, that's the big question we're answering today.
So, what is an IP address? Well, the absolute simplest way to think about it is like a physical home address, but for the digital world. It is a unique identifier that tells the internet's postal service exactly where to send information and where to receive it from. Without it, all that data would just be lost mail.
And this digital address, it's actually doing two critical jobs at the exact same time. First up, identification. It's what makes your specific phone or laptop distinct from all the other billions of devices out there. And second, location. It provides the actual address for that device on the network. So one tells you who the data is for, and the other tells you exactly where to deliver it.
Okay, so if it's an address, what does it actually look like? Let's break down the different formats. You can think of them as different kinds of street signs you'd see online.
For a really long time, pretty much the whole internet ran on a system called IPv4. This is the format you've probably seen before. It's just 4 sets of numbers, each separated by a dot. Each of those numbers can be anything from 0 to 255. Seems simple, right? Well, there's a catch.
And here's the catch. That structure only allows for about 4.3 billion unique addresses. Back when the internet was just getting started, that seemed like an infinite number. But today, with our phones, our laptops, our smartwatches, even our smart refrigerators, we have just plain run out of room.
So to fix this, in comes the solution, IPv6. And the number of possible addresses here is, well, it's just mind-boggling. We're talking 340 undecillion. That number is so massive, it basically solves the address shortage problem forever. To put that into perspective, it's enough to give multiple IP addresses to every single grain of sand on Earth. Yeah.
But hey, this upgrade is about way more than just size. It's also about being smarter. As you can see here, besides the huge jump from 32 to 128 bits, the real key is efficiency. You see this thing called the header? That's like the addressing info on a data packet. In IPv6, it's a fixed length, which makes it way faster for routers to process. Plus, where IPv4 needed a whole separate system to find devices locally, IPv6 just builds that function right in. It streamlines the whole process.
Okay, but here's a cool thing. Just like with real-world mail, not every address is meant for the whole world to see. This brings us to the difference between, say, your apartment building's Main Street address and the specific number on your apartment door. So get this. Every single device you have hooked up to your home Wi-Fi actually has 2 addresses. Your public IP is your Main Street address assigned by your internet service provider. It's what the rest of the world sees. But inside your house, your router assigns a private IP to each device, your phone, your laptop, whatever. And that's like an apartment number that's only used right there on your local network.
So how does this all work in practice? Well, your router, it's basically the mailroom clerk for your home network. When your laptop sends a request using its private apartment number, the router swaps that out for the public street address before sending it out to the internet. Then, when the response comes back to that main address, the router knows exactly which device, which apartment it was for, and delivers it correctly. This whole clever process is called Network Address Translation, or NAT, and it was a really critical workaround for that IPv4 address shortage.
Okay, so we know your device has an address, but when you type something like google.com into your browser, how does your computer find its address? I mean, you don't type in a string of numbers, you type in a name.
And the answer to that question is something called the Domain Name System, or DNS. Honestly, the best way to think about it is, it's the internet's phone book. Its entire job is to translate the human-friendly website names we all type in to the machine-readable IP addresses that computers actually need to find each other. It's the critical link between us and the machines.
And this whole lookup thing happens in like a flash. Your browser asks a resolver for the address. Think of the resolver like a super fast librarian. It checks the master directories, the root and top-level domain servers, to find the right section. Then it finds the specific authoritative server that holds the final correct IP address and sends it right back to your browser so you can connect.
So, we've talked about how this whole system is brilliantly designed to make sure data finds its way straight to your unique address. But what does that public address say about you? This is where an IP address stops being just a technical detail and starts being about your personal privacy.
Because here's the thing. Your public IP address is, well, it's public. And it can reveal way more than you might think. It can pinpoint your general location, sometimes down to your city or even your zip code. It clearly identifies your internet provider. And since it's a consistent ID for your network, it can be used to track your browsing activity across different websites.
And this isn't just theoretical stuff. This data has real-world consequences. It's used for everything from serving you ads based on your location to blocking you from watching content that's not available in your country. And more seriously, scammers can use it to make their phishing attacks seem more believable, or hackers can use it to probe your network for weaknesses.
So this is exactly why you hear people talking about VPNs, virtual private networks, all the time. A VPN pretty much acts as a privacy shield. It routes all your traffic through one of its own servers, which does two things. It masks your real IP address with the server's IP, hiding your location, and it encrypts your data so your own ISP can't see what you're doing. It just makes it much, much harder for anyone to track you online.
At the end of the day, your IP address really is your home on the internet. It's absolutely essential for getting connected, but it also reveals where you live online. So the final question you have to ask is, who do you want to have the key to your digital door?